Hello and welcome to Protomotive. We thought we'd have a little fun today and show you one of the tools that we have on our website here. We've got a couple shown on the screen here. We've got our HP gains, horsepower gains calculator, and also a little piston motion simulator, which is showing rod angles and other stuff here in the background. But let's take a look first at the horsepower gains calculator. What we've done here is a little different. Most horsepower gains calculators that you'll find on websites these days are mostly based on real intricate calculations of having to know a lot of details about the engine, the flow of the ports, the camshaft duration, specifications, really intricate details, engineering grade stuff to create a a baseline for your engine to figure out what it can possibly do. We're doing it a little differently here, and what this is doing is what most of you are doing. You have a car. This one in particular that we're showing here happens to be a 3.2 Carrera, 1984 to 1989. It produces 231 horsepower at 5950 RPMs, bore of 95 millimeter by 74.4 stroke, 6 cylinders, 9.5 to 1 compression ratio for US models. Boost, we've got a tiny amount of vacuum there because it's got a barn door airflow meter on it. Ambient temperature here, we can flip back and forth, 60 degrees, that's just for correction factors. No turbo, no intercooler. Okay, so that's what you bought. That's what you're driving around. So, do we need to calculate that again? No, we already have that. Porsche's done their homework. They've built a fantastic car. It's a great engine. So, we know the baseline efficiency of that car. So, let's take that and modify it. That's where we are at target modifications here. This particular example we're showing, we're going to put a little cam in it. So, we're going to take it from 5950 to 6500 RPMs. This is already in there when you open this up. And actually, let me back off just a little bit. To get here, go to protomotive.com, go to Tech Library, and click on Protomotive Horsepower Gains Calculator, and it'll bring you to this page. So once you're here, again, you've got your baseline specifications. These are all pre-filled out for you. So you get started. It just happens to be using the 3.2 Carrera because we've done so much work on these in the past and built turbo systems and naturally aspirated engines and all kinds of stuff based on this particular engine. So it always felt right to use that. So the engine we're building here happens to be with a little cam. We've got a 100 millimeter bore, 76 millimeter stroke, 6 cylinder, 8 to 1 compression ratio because we're going to turbocharge it. We got a bar of boost. Ambient temperature's the same. That hasn't changed. We're approximately in the 75% turbo efficiency island here. And our intercooler efficiency, we've got one of our big badass intercoolers on there at 85%. And voila, the estimated results are 633 horsepower with that combination of a 3.6 liter. So that takes us from our 3165, which is our 3.2 Carrera, to 3608 cc's. Our original compression ratio is 9.31. That's because you've got a static compression ratio of 9.5 to 1 with a little vacuum. So then we boost it. We're 8 to 1. So why isn't this compression ratio 8 to 1? Because it's the effective compression ratio. The effective compression ratio is going to be all our factors moved together, our static compression ratio times our boost, which would be 16. But then we lost a little efficiency. So because we're putting heat in it, that's going below our ambient temp, actually above our ambient temp, sorry. We started at 15 degrees C, which happens to be 60 degrees Fahrenheit for corrections. And we've gone to 82 degrees Fahrenheit, which is almost 28 degrees C. So because of that, the density's gone down and our compression ratio, our effective compression ratio has gone down. So let's go ahead and back off on this, or let's have a little fun with it. And let's say we want to do a naturally aspirated 3.6 instead. And we're going to run that at 10-to-1 compression ratio with no turbos, no intercoolers. So we've just now spent from a 3.2 to a 3.6. I'm sorry, static compression ratio 10-to-1, ambient temp is still there. We've gone from a 3.2 all the way to a 3.6. Full engine build. We've got a cam in it. Still similar manifold. The ports are really good. Same size valves. We've gone from our baseline power of 231 up to 291. So we've picked up 60 horsepower going from a 3.2 to a 3.6 liter. Yeah, we can take that and we can go to a 3.8 liter. Now we're at 303 horsepower, which is sounding pretty nice. If we left the stock cam in it, the RPMs would be the same. So we'd be about 277 horsepower. So you can have a lot of fun with this and explore a bunch of different things. Let's say we left our 3.2 Carrera engine alone, still 3.2 liters. So let's go back to the 95 millimeter bore on the 74 millimeter stroke, 6 cylinders. And the only thing we want to do is jack up, let's go back to 9.5. So we're still 230.94, almost 231. So we want to put 11-to-1 pistons in it. Okay, so spent a lot of money, put pistons in it, did a full rebuild on it, just jacked up the compression ratio. We went from 9.5 to 11-to-1. We made a whopping 9 horsepower. Not really that impressive. And if you're out in California, you're stuck on 91 octane. It's not going to work well. You'll probably end up knocky. You'll have to end up running race fuel. So let's say we want to go nuts and we're going to run 15-to-1 compression ratio. Okay, voila. Now, if we had fuel that would actually support that, that would take us up to 257. But what's interesting is if you double the compression ratio, you're not, as you can see, you're not getting great gains. So compression ratio is not what a lot of people think it is. It's got to work with your fuel, your octane, your build, your camshaft. You can run more compression when you have bigger cams in there because you're blowing a lot of the combustion out with the exhaust valve really opening. So let's have a little bit more fun here. Let's turn this into a 3-liter naturally aspirated RSR engine. So they're what, 95 by 70.4. That thing ran like 7,800 RPMs. Compression ratio, I think they were like 10.3, maybe 11-to-1, something like that. Individual throttle bodies, so we'll get rid of that. Still no turbo, no intercooler. It's about right. 305 horsepower. We're right at 100 horse a liter out of 3-liter RSR type engine with individual throttle bodies. So if we wanted to take that and go nuts, and let's make it a 4-liter. Let's go with a 80.4 stroke on, let's say, what's it, 102.7, yeah, 3996 cc's, same compression ratio. So we can make 407 horsepower out of a 4-liter, but we're having to rev the wee out of that thing. Not really that much fun. So to make the same 400 horsepower on a 3.2 Carrera, let's put one of our little stage 1 turbo kits on it. Go back to 95 millimeters, 74.4. Compression ratio is stock. Boost, 7 pounds of boost or half a bar. Turbo is decent. Intercooler, we've got no intercooler on it. 50 and 50 on that. And there's our 335 horsepower on our stage 1 bolt-on, which is what we rate those at. If we take the intercooler efficiency and do a stage 1 upgrade, all of a sudden we've gone to 380 horsepower. But with an intercooler, you can go to 9 or 10 psi boost. Let's see, can we get psi? Yeah, there we go. Let's go 10 psi boost. Actually, let's go 9 psi boost. We rate those at 410. It's saying 415. Might be a little happy on that one, but very close. I mean, within a couple of percent. So what do you want to do? What do you want to build? And do you want to start from ground zero and try to calculate all the port flows, all your compression ratios, everything else, you can really play around a lot with this and learn a lot as to what it takes. Now, I mean, we can go nuts on this thing. Let's take a 3.2 and de-stroke it. I tried doing this a while back. De-stroked a 3.2, put a cam in it. Let's try to run the RPMs up on it, and 7,500, or let's go 7,800 individual throttle bodies. A de-stroked 3.2 is actually a 2.8 liter. Sorry, we were boosted there. Let's go 0 boost, 0 turbo, 0 efficiency. So all that work, we've de-stroked it, and we've picked up 45 horsepower, 44 horsepower. That's an awful lot of work for very little gain, and we're revving the wee out of it again. You're going to have to drive that thing hard. It's going to be like a Type R Civic or something like that, versus displacement. As you saw, we go big displacement on these things. 102.7, we take it out to 82.4 even. We'll do a 4.1. Heck, yeah, our later ones are 103.6. Let's mimic a 4.2 liter 996 turbo engine running a GT3 intake manifold that makes peak power at 7,600 RPMs. We're at 8:1 compression ratio. Let's just put it at 1 bar boost only. Turbo's still around that. Really good intercooling. And without working hard, big displacement, we're at 855 at low boost. Even at lower boost at 0.8 bar, which is stock boost of a 996 turbo, we're 759 horsepower at the crank with a big engine. If we just did it at 4.1 liter, 80.4, we're still 741 horsepower at the crank at only 0.8 bar, running RPMs that the GT3 intake will. If we leave the stock cams and the stock intake on it, leave that alone, 12 pounds of boost, big displacement, 634 horsepower at stock boost pressure, which I don't know about you, but I'd love to drive that around all day long. These things are just dead reliable at that boost pressure. Basically stock cams, big displacement, low boost, good intercoolers, good turbochargers on it, and really nice power band. So what do you want to build? Yeah, you can change your baseline engine. If you wanted to start out with a 5 liter V8 from your Mustang, if you wanted to use your Macan and turbocharge it, you can input your base engine in with some very simple terms that gives you your base efficiency. Once you've got your base efficiency, you can tweak it and get very accurate estimation of where you're going to go, rather than working really hard trying to build something from the ground up, trying to understand everything, since most of us already have a car and all we want to do is tweak it and play with it a little bit. And that's what you're able to do here on this. So again, to get to it, go to protomotive.com, go into our tech library, Protomotive Horsepower Gains, and it'll pull up this page. It'll already be pre-filled out. You'll have some numbers there to play with. Just start playing around with it. See what it does. Now, this other little one we've got over here, we're having some fun with. The piston motion simulator. There's a lot of talk about rod and stroke length ratio. We should probably do this in a whole separate video. So let's do that in a separate video. Thanks for watching. We'll talk to you later.